Hey guys, so just wanted to do a quick video tutorial on how I managed to get the neural app modeler trainer to basically train locally on my PC and not use the Google Colab cloud. For people that aren't aware, there's now an open source solution that can actually do pretty much what Kemper did, and it's miles better than what Kemper does, Tonix from IK Multimedia, and even the quad cortex from Neural DSP at this current stage point in time. Um, there's a way to use this pretty much hassle-free, but with a caveat in the Google Colab Cloud. And our friend over here, Jason Zdora, has done a pretty good vid on it, on how you can actually use it in the Google Colab Cloud. The catch to that is the fact that Google basically can kick you out at any point in time, or if you just really want to run longer training models, just fine tune, get really nice models. They can pretty much kick you out anytime because obviously paid subscriptions take precedence. So that said, if you have an NVIDIA GPU, you can actually run the trainer. You can train your own models on your PC, and you can pretty much go crazy with the app box or the fine-tuning the steps to get some really good models. The way to do that is pretty much highlighted over here. So I'm just going to walk you through this step by step. So disclaimer, I already did this on my PC. I'm just going to walk through these steps once more with you folks. So basically, you start off by installing Git. Which is going to allow you to clone, to get the clone, to pull the code that Steve has posted on GitHub. So you just go to GitHub. So I'm going to paste all of these links in the description of the vid, hopefully, so everybody can just click on them and you're going to be taken to all the appropriate places. But you basically click on this one, the Windows installer, and you just download the latest and greatest. I already have it here, so I'm just gonna run it again. Hopefully it's not gonna yell at me because I already have it deployed. And just another disclaimer, I have to give credit to Helga Behrens. There was a post in the Facebook group around the December timeframe, and I pretty much used this along with poking Steve's brains on a couple of steps to get this working. So yeah, thank you very much. Wouldn't have been able to get it running without these resources. So back to Git, you just leave whatever is in there by default. You don't necessarily need an icon, so just go next. I use Notepad++ as the default editor. You don't necessarily need this, but just in case. And then you just go click to this, leave everything on defaults, right? And it's gonna do its thing, right? Right, and not just gonna view any release notes. I'm not gonna look at anything now. Now, what we want to do is basically clone and pull the code that Steve's posted on GitHub. And to do that, first of all, I want to create a folder on my desktop, which is going to be where I dump the code. Another thing that you need is the training signal, which Steve also provided, and you can actually grab it from the Google Colab page. And it's linked in Jason's vid as well, and the wet signal. So basically, the wet signal is pretty much the training signal ran through your AMP and then back into your PC, right? So have these ready, and this is probably what well, not probably, this is what we are going to use when we get to the training the model step. All right, so we have the folder created, and then we're gonna have to pull the code into our folder. So the way you do that is basically, I just looked up a resource, a tutorial on how you actually pull code from a GitHub repository, and it's pretty much just this command, and then a URL that's listed next to the code under the code icon. So basically just go here on Steve's page, right, and just go code, and you can just click this and it's going to copy the link, right. Next thing you do is you just open the Anaconda shell, and what you do, I'm gonna try to navigate to my NAM folder because that's really where I want to get the code. So I'm just gonna do cd bang, and I'm just gonna go git clone, and let me just make sure that I have the right all right. So now that's done. Well, I should have installed Anaconda first, but anyway, the Anaconda install is pretty straightforward. After you do git, you can pretty much install Anaconda. So I'll probably you probably want to flip those around. Although I think you can do it from the Windows command prompt as well. If you go, let me see, and just put that to the test. Well, yeah, so it will allow you to do that. So just for your own peace of mind, you might want to flip this around. So just do install Anaconda. Yeah, the command prompt should work just fine. So the Anaconda install is pretty straightforward as well. I mean, you just run the installer. You just grab it from the website, from the Anaconda website. Just click download. It's gonna dump the kit into your downloads folder. You just click next, 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 next. Right, so mine already has it. So I'm just gonna board the installation, but it's pretty straightforward. I mean, it just takes a little bit of time, but it does its thing. All right. So we have installed Anaconda, install Git, clone the repo. Now we just need to install the nVidia CUDA toolkit. So the way you do that is pretty much you navigate to, or you just use Google Foo, just do a search for CUDA toolkit 11.6, and you click on this link over there. Select your architecture, your Windows, and the executable for the local installation. This installer is gonna get dropped into your PC. You just run it. Right, should be pretty fast depending on your PC. And this is one of those installs where you just click next all the way through the install and just go with the express settings. There's really nothing else to it. Right, for the sake of it, I'm just gonna show you how it is, and yeah, it should be you agree to the license terms, express. You acknowledge this that you don't, there's no Visual Studio integration, and you just click next, install, and it's gonna finish, right? So make sure you don't cancel what I did. I mean, I already have it installed. Right, so next thing we want to do is we're gonna want to install the machine learning library, so which is PyTorch. So to do that is basically just navigate, or you just go back to with an Anaconda command shell, a prompt shell or a command prompt. Just navigate to your folder, right where you installed. Not necessarily, you don't necessarily need to be there. And you just run this command: conda install PyTorch CUDA 11.6 PyTorch -c nVidia. Right. Okay. And it might yell at me because I may already have it deployed, but just for the sake of it, this is what you will need to do. Just word of warning, it does take its sweet time, so just let's see it unfold. All right, so mine was already installed, so all the dependencies are met. And yeah, we have Git, Anaconda, we got PyTorch deployed, and then last of the prerequisites is pretty much to install them on our machine, right? So you just change directory and you navigate. So when you clone the code, it's gonna create a small folder over here, the neural app modeler. And we want to just go in here. Right. All right. And what you do is you go pip install -e dot. All right. So my requirements are already satisfied, but this is pretty much what you need to do. And that's pretty much it. You don't have to do this ever again on that machine. Right. So that's out of the way. The only thing that you would want to do when you want to train a model is pretty much this, the steps over here under this section. So assuming that that's out the way, what you need to do is you get your files over here, your wet and your dry signal, and you just copy them over here in the neural app modeler folder, right? Then you're gonna open an Anaconda. PowerShell or command doesn't necessarily make too much difference in my experience for the training. All right, you fire up Python. You import the torch library. And this one hangs a little bit depending on how fast your machine is. And then we're gonna bring in the NAM training module function, whatever. This is pretty much the workhorse that's gonna use those files and the binaries that Steve wrote to, the scripts to put together our lovely little model of our AMP, okay? Now, and this is where the magic happens. So this is how you call up, you start the training. This is where you put in the epochs. The way I understand it is pretty much each epoch is pretty much a training run over the signal. So the more of these you do, the better your model is going to be, the more fine-tuned. There is, in my experience, for high gain tones, there is a point of diminishing returns. So probably around the 600 epoch mark, you may not get any how should I say it, any considerable improvements to your model. But for all intents and purposes, just try it out and see. Usually I go for 1000 epochs. For this demonstration, I'm just gonna go with I don't know, 20 or let's say 15. That's gonna take like 5 minutes or something. I just want to have enough time to show you how you can actually visualize the graph and see how your model is actually behaving and how it's being fine-tuned. All right, so once you hit enter or return, this lovely graph is going to pop up. The NAM model is automatically going to detect the delay in between the start of the wet and the dry signals, and it's gonna show you, over here. Word of warning, don't leave this on your screen and look at it because the training is not going to start, not in this iteration of the NAM modeler. So once you close the graph, the training is going to start. If you don't close the graph, the training is just going to be halted. All right, so don't. So this is how the training looks like, and to actually see a graphical representation of your progress, you can pretty much open another Anaconda prompt, right? Navigate to to your NAM folder and then just run this command. Tensorboard, sorry. All right, without this at the end. All right, so it's gonna tell you, hey, go to this, open this in your browser, and you can actually see the progress that's being made. All right, so you're pretty much going to be able to have a look at. So this ESR is pretty much an indicator of the quality of your model. The lower it is, the better your model is going to sound. I mean, the more accurate it's going to be compared to the source, the amp that you're actually trying to capture. Steve, in Steve's tests and trials, he said that usually around the 0.01 value, ESR is pretty much, an absolutely great model. But in my experience, I've had very good results even with 0.02, 0.04. It really depends. What I found is that the higher the gain in your actual amp that you're trying to capture, if it's boosted, like crazy boosted, or if you have clipping diodes, the higher the ESR is going to be. So you won't be able to get very, very low to the to those low levels, right? So if you look at the run.pi file, I know Steve posted this. Where was it? Sorry, no, I'm just a little bit confused. There was. I don't recall where I saw it, but I know I was looking through the files. I know I saw the criteria, so the ESR thresholds. Basically, if it's over 0.035, you might have a chance of it sounding decent, but yeah, I mean, the lower you can get this, the better it's going to sound, and that's where those epochs come in. So you'll see that the longer this training takes, the longer the training goes on for, um, well, the better the ESR is going to be, supposedly. I mean, once you cross that 500 epochs threshold, in my experience, it doesn't necessarily get any better. When the training finishes, you're gonna see this this graph, right? So the ESR in my case is 0.049. It's not too good, and you'll see it over here as well. This is Steve's way of telling you, hey, don't get your hopes too high. It might sound good, but you might want to do another training round, and this time around not with 50, but might 500 epochs. Yeah, you'll also see that your model was exported. Sorry, no. If you want to see, sorry, unless you close this graph, your model is not going to get published, and that's gonna, have you scratching your head, because if you keep this graph open and you just go in the NAM folder looking for your model, you won't find it. Right, you're gonna find the lightning logs version. You want to take the checkpoints. Basically, Jason's gonna go through this or he has already went through this in his vid. You'll see them in the Google Colab because you're gonna keep an eye on these. But you're not gonna find your model. So what you need to do is close this graph. Right. So once you close that graph and you come back over here, all right, you'll see that the model was exported to exported models version 1, which is going to be, right? We now see the folder, exported models, version 1, and there we go. So what you can do is open Reaper or whatever DAW you're running. Just go insert track, effects, get Steve's plugin, which is the neural app modeler plugin that I have. It's different. So the plugin is at a different GitHub location than the actual trainer. All right, so you can basically just go to this page and you can just go click releases. And you can just pretty much download the Windows zip file and then run the binaries on your PC. Run the executable, or sorry, unzip this. Right, and you just follow the prompts. Right, and that's gonna install Steve's plugin, which is able to load these model.nam files. Okay, so just gonna go with this. Right, and this is what you'll see. And then you're gonna select the model. You can go to desktop. We went to neural amp modeler, exported models, and you can basically just copy that model anywhere that you would like and rename it. You can even rename it to something else. Just click on it. Right, it's gonna be there. Select the an IR that you would like to use. I'm a pretty big fan of the York audio stuff, so I found that the plugin, so the plugin is gonna run the best at 48K. 96K is gonna crap out even after you've trained your model. So in my experience, it doesn't work too well. But the IR section can actually load 96K IRs as well. So yeah, just try it out. Yeah, just load one IR and have at it. That's pretty much it. There's no noise gate, so you might want a noise gate plugin in front. But yeah, that's pretty much it in a nutshell. Hope this helps, and yeah, happy jamming. Thanks a lot, Steve.